Mount Meager is moving right now, not in some distant geological sense. Right now, today, as you watch this, the slopes of Canada's most dangerous volcano are creeping downhill, millimetre by millimetre, deforming under their own weight. Satellites have measured it. Scientists have mapped it. And almost nobody in Canada knows it is happening. This is not a metaphor. Using a technique called satellite radar differencing, researchers have tracked the actual physical movement of Mount Meager's flanks over time. The unstable slopes, the same slopes that failed catastrophically in 2010, are not sitting still. They are slowly, silently deforming. And the peer-reviewed conclusion of the scientists who measured that movement was blunt. The slopes will continue to deform, possibly leading to catastrophic collapses similar to the 2010 event. Here is how that measurement works. Because it matters. A satellite passes over the same mountain again and again, bouncing radar off the surface and timing the return with extraordinary precision. By comparing the radar from one pass to the next, scientists can detect changes in the position of the ground down to the level of millimeters. A slope that has moved a few centimeters between passes shows up clearly in the data. It is the same basic principle a doctor uses when comparing two scans taken months apart, looking for the thing that has changed. And when researchers ran that comparison on Mount Meager, the mountain failed the test. Multiple slopes were measurably creeping, deforming, inching toward failure on a timescale invisible to the human eye, but obvious to the instruments. A team of geoscientists, including researchers connected to Simon Fraser University, published these findings after studying the mountain in the wake of the 2010 collapse and the 2016 fumarole discovery. Their geomorphic study identified the unstable slopes, measured the movement, and documented the glacier retreat, all pointing to the same conclusion. The ice will keep thinning. The slopes will keep deforming. And another catastrophic collapse similar to 2010 is not just possible. It is, in their assessment, likely. The 2010 event was the largest landslide in Canadian history. More than 45 million cubic meters of rock came off this mountain in the dark, at 3:27 in the morning, moving fast enough to send seismic waves more than 2,000 kilometers away into Alaska and Washington. It was a near miss. It stopped about 10 kilometers short of the nearest homes, and the mountain that produced it is moving again, the same way, from the same kind of slopes, while Canada watches with almost nothing. So what does it actually mean when a volcano starts moving? Why are the slopes of Mount Meager deforming in the first place? And what makes scientists so sure the next collapse is a question of when and not if? What is sitting downstream in the path of a mountain that has already produced the biggest landslide this country has ever recorded? And why in 2026 is Canada still almost completely unable to see it coming? To understand why Mount Meager moves, you have to understand what it is made of. Most people picture a volcano as solid rock. Mount Meager is not solid. It is rotten. For tens of thousands of years, hot acidic fluids from the magma chamber deep below have been rising up through the mountain, soaking through the rock, chemically eating it from the inside. The process is called hydrothermal alteration. In plain language, it turns hard volcanic stone into something with the structural integrity of wet clay. Mount Meager is quite literally decaying from within. And the parts that have decayed the most are the parts most likely to slide. Think of it like a building whose steel frame has been rusting in secret for a century. From the outside, it looks like a mountain. Inside, the structure has been quietly converted into something soft, weak, and crumbling. You cannot see the rot from the surface. You only find out it is there when something fails. Now add the second ingredient, ice. For thousands of years, the slopes of Mount Meager have been held in place by glaciers, enormous masses of ice pressing against the mountain's flanks, acting like a buttress, holding the rotten rock in place. That buttress is now melting. The glaciers on Mount Meager are thinning and retreating faster than at any point in recorded history. And as the ice pulls back, it stops holding the slopes in place. The rotten rock is left exposed, unsupported, and free to move. Imagine pulling away the one bookend holding up a leaning shelf of books. For a while, nothing happens. The books lean. And then, all at once, they do not. That is exactly what happened in 2010. A warm spell melted snow and ice high on the mountain. The water saturated the already weak, hydrothermally altered rock of the south flank. And then a 2,500-meter peak called Capricorn Mountain simply let go. The entire south face of Mount Meager slid off the mountain in a single mass. It came down in the dark. 3:27 in the morning, August 6th, 2010. There were no witnesses, because there was no one there to witness it. The first sign anything had happened was the seismograph reading. The collapse was so violent it registered as a magnitude 2.6 earthquake, and the seismic waves traveled more than 2,000 kilometers, all the way into Alaska and Washington state. A mountain falling apart, recorded as an earthquake on another country's instruments. The numbers are hard to hold in your head. More than 45 million cubic meters of rock. Some estimates put it closer to 53 million. Enough debris to bury a city block under 100 meters of rubble. It traveled down Capricorn Creek at an average speed of 64 meters per second. That is 230 kilometers per hour, faster than any car most people will ever ride in. When the debris flow hit the bend where Capricorn Creek meets Meager Creek, it was moving so fast it ran 270 meters straight up the opposite valley wall before gravity pulled it back down. It dammed the Lillooet River entirely. It blocked Meager Creek for 19 hours, ponding 2.65 million cubic meters of water behind a wall of fresh debris, a temporary lake that threatened to burst and flood the valley below. And it did all of this in about 2 minutes. The only reason nobody died is that it happened at 3:27 in the morning in a remote valley, and the debris stopped about 10 kilometers short of Pemberton. Change the timing, change the release point, change the size, and 2010 is not a near miss. It is a disaster. And here is the part that should land. The scientists who studied the mountain after 2010 did not find a system that had calmed down. They found one that is still moving, still deforming, still rotting, still losing its ice. The exact conditions that caused the 2010 collapse are not historical. They are ongoing, and in the case of the glacier retreat, accelerating. If you had no idea that the slopes of a Canadian volcano are measurably moving right now, drop a comment. I want to know how many people are hearing this for the first time because it is not a secret. It is in the published research, it just never reaches the public. In 2016, the mountain gave another sign. A helicopter pilot flying past the Job Glacier on Mount Meager looked down and saw 3 dark holes in the ice, with vapor rising out of them. Fumaroles, vents where hot volcanic gas was burning straight up through hundreds of meters of glacier ice, melting caves into the glacier from the inside. Nobody had known they were there. The discovery was almost accidental. The pilot happened to have an eye for geology, recognized the plumes for what they were, and reported them. Within weeks, a research team was on the glacier, lowering instruments down into the caves the volcano had melted into its own ice. Inside, they found heat, gas, and steam, a window straight down into the hot plumbing of a living volcano. The reason these vents became visible is the same reason the slopes are failing. The ice is thinning. As the glacier retreats, it exposes the hydrothermal system underneath, the hot, gassy, acidic plumbing of a living volcano. The mountain had been venting that whole time. We simply could not see it until the ice got thin enough. Those fumaroles matter for 2 reasons. First, they confirm the magma system below is still hot and active. Mount Meager is not a dead volcano. It is a sleeping one, and it is breathing. Second, the gas they release, including carbon dioxide and sulfur compounds, is part of what makes a future event so dangerous. Volcanic gas is invisible, heavier than air, and can pool silently in low ground. The same kind of gas, in a different Canadian volcanic eruption around the year 1700, killed up to 2,000 people while they slept. Most of them never knew what was happening. They simply did not wake up. So what is actually downstream of all this movement? Start with the Lillooet River Valley, which runs directly from the base of the mountain toward the communities below. The 2010, debris flow traveled down this exact drainage. About 65 kilometers downstream sits Pemberton, a town of roughly 3,500 people. Just beyond it, Mount Currie, home to the Lilwat Nation. Further along the corridor, the resort town of Whistler, and woven throughout the valley is critical infrastructure, including hydroelectric facilities and the only highway connecting these communities to the outside world. And there is a new wrinkle the older studies flagged with concern. There has been growing interest in building hydropower infrastructure near the volcano, drawing on the very rivers that drain its slopes, and continued population growth in the Lillooet River Valley downstream. In other words, over the same years that the science has grown more certain about the danger, more people and more infrastructure have moved into the path. The exposure is going up at the same time the threat is going up. That is the opposite of what risk management is supposed to look like. Here is the detail that makes geologists most uneasy. The official peer-reviewed worst-case modeling for a future Mount Meager collapse is not the size of the 2010 slide. It is up to 10 times larger, 10 times the largest landslide in Canadian history. The valley below absorbed the 2010 event only because the slide stopped in time. A slide 10 times bigger from the wrong part of the mountain does not stop in time. It reaches Pemberton. And the researchers who modeled this concluded years ago that the level of risk posed by large landslides at Mount Meager is unacceptable. Their word, unacceptable. And they noted that despite this, little had been done by local or provincial governments to manage the risk over the past decade. If this is the kind of story you want more of, the ones built on the research that never makes the news, this channel is exactly that. Subscribing is the easy way to keep them coming. Which brings us to the uncomfortable center of this whole story. Canada cannot currently see this coming in real time. For a mountain that is actively deforming, venting gas, losing its ice, and carrying a peer-reviewed worst-case scenario 10 times the size of the country's largest recorded landslide, the monitoring has been almost non-existent. 2 cameras. 1 citizen science seismometer that does not even string its data live. That is what has been watching Canada's most dangerous volcano. The seismic network in the region was built to detect large tectonic earthquakes, not the small, shallow signals of a volcano waking up or a slope about to fail. A critical warning sign could happen and simply not register. That is finally about to change, but only barely. In spring 2026, a team led by volcanologist Dr. Glyn Williams-Jones of Simon Fraser University is installing Canada's first ever continuous real-time volcano monitoring station on Mount Meager, a seismometer, a GPS unit to measure ground deformation. Infrasound sensors, a real-time camera. For the first time in this country's history, somebody will be able to look at a live screen and see what the mountain is doing. Williams-Jones put it simply. If we are not looking, we cannot take the pulse. We cannot say whether the patient is awake. The GPS unit is the part that matters most, for the slopes that are already moving. Right now, the deformation is only measured when a satellite happens to pass overhead, and a researcher later compares the images, a process that can take weeks or months. A permanent GPS station on the mountain changes that completely. It would measure the position of the ground continuously, in real time, to the millimetre. If a slope that has been creeping slowly suddenly began to accelerate, which is the classic precursor to a catastrophic collapse, the station would catch it as it happened. That acceleration is the signal that separates a slow creep from an imminent failure. It is the single most important thing to watch for, and until this spring, nothing has been watching for it in real time. But Williams-Jones has also been clear that one station is not enough. The international standard for a high-threat volcano is around 12 instruments. He wants at least 6 on Mount Meager alone. The first one is a start, not a solution. And it is going up on a mountain whose slopes are already in motion. The baseline of what normal looks like for Mount Meager does not even exist yet because nobody has ever measured this volcano continuously in real time. The instruments will be establishing what normal is at the same moment they might be recording something that is anything but. We are, in a very real sense, about to start watching a mountain that has already started to move. So what does what comes next actually look like? Be honest about the range. The most likely near-term event is not a dramatic eruption. It is a landslide. Another collapse of the unstable, deforming, ice-starved slopes, similar to 2010, but potentially far larger. That is the threat the deformation data points to most directly. The second possibility is a phreatic event, a steam explosion, where groundwater hits the hot rock of the hydrothermal system and flashes to steam, blasting out rock and ash without fresh magma even reaching the surface. The third, and least likely in the near term but most catastrophic, is a full magmatic eruption like the one 2,400 years ago that sent an ash column 15 kilometers into the sky and dropped ash as far away as Alberta. Any of these would hit a country that, by the admission of its own scientists, is not ready. There is no published evacuation plan for Pemberton in the event of a Mount Meager debris flow. There is no detailed public ashfall protocol for the sea-to-sky corridor. The federal framework for responding to a volcanic event in Canada dates back decades and was built primarily around aviation hazard, not around the populated valley sitting downstream. The monitoring is one station, going up this spring on a mountain that is already moving. If you know someone who lives in Pemberton, Mount Currie, Whistler, or anywhere along Highway 99, send them this. Most of them have no idea the mountain up the valley is in motion. and that the people whose job it is to watch it are only now getting their first real set of eyes. Here is where it all lands. Mount Meager is the most dangerous volcano in Canada. Its slopes are made of rock that has been chemically rotting for tens of thousands of years. The glaciers that held those slopes in place are melting away. Satellites have measured the slopes actively deforming. The mountain is venting volcanic gas through holes in its own ice. It has already produced the largest landslide in Canadian history once, in 2010, and the peer-reviewed worst case for the next one is up to 10 times bigger. And until a single monitoring station powers on this spring, the country has been watching all of it with 2 cameras and a hobbyist seismometer. The patient is not just asleep. The patient is twitching. Slowly, silently, measurably, the mountain is moving, the same way it was moving in the years before 2010. The difference is that in 2010, nobody was watching closely enough to see it building. This spring, for the first time, somebody finally will. The question in the title is not really whether Mount Meager has started moving again. It never stopped. The real question is whether the instruments go live in time to catch the moment the slow creep becomes a sudden fall. Because the mountain has done it before, in 2 minutes, in the dark, with no warning at all. And the next time, there are 3,500 people sleeping at the bottom of the valley. If you made it to the end of this one, you clearly care about the things most people scroll right past. Subscribe if you want to see the next one before it becomes the headline.